Hello and welcome back. So previously we've defined what a Boolean expression is, and we showed you how to simplify a Boolean expression. In this video, we'll be talking about how to go from a Boolean expression to a logical circuit, which is relatively a simple exercise or thing to do. So let's get started. First, we take a look at the highest level operation, which is the OR over here. So we put down an OR gate right here. And what are the two sides of the OR? The first side of the OR is A and not B. So we get A and not B, which gives us this little guy. And that would be the first input to the OR gate. And then we have another term, B and C. So basically we would have something like this. Note that this line doesn't have B going through the not gate. Therefore, we have not B and C. And we feed this into the OR gate, and eventually we get a Q. This is a terrible drawing, but you get the idea, right? Okay, moving on to a slightly more complicated case. I want you to try this at home by yourself before I show you the answers. I would recommend you pause the video right now and come back when you had some time to work on it on your own. Okay, hopefully you pause the video, and now I'm going to show you how to draw out a expression, the logical circuit that's the same as this expression. So same thing as before, we start with the highest level operation connective, which is the OR, and then we look at what are on the sides of the OR. So the left hand side gives us not A and B, which is the NAND gate. So we can just feed these into the NAND gate. Sorry about that. That is a terrible drawing. The NAND gate, and that would be one of the inputs to the OR gate. And the next one gives us a bigger expression. Let's look at the next higher level expression operation, which is this AND right here. So we put down an AND right here. And let's look at the first argument to the AND, which is the not A. So we can just pull this A here, pass it through a not, and give it to the AND. So what is the other side of the AND? Sorry about that. The other side of the AND is another OR expression. So we put an OR gate right here. That would go into the AND gate. And the two arguments of the OR gate is B. So like that and like that. And then we get Q. Once again, I'm terribly sorry for this terrible drawing. Oh, crap. Sorry about that. I made a mistake right here. Some of you might have noticed, but this is supposed to be a NOR gate, not a NAND gate, since we're using an OR here, not an AND. Sorry, that was my mistake. And yeah, but we just learned how to simplify Boolean expressions. And in fact, we can apply those simplification rules before we draw out the circuit. So let's try simplifying this. So by applying the De Morgan's law, we get not A and not B, and then applying the distributive law, we get not A and C, or not A and B. By applying the idempotent law, once again, the law that I don't know how to pronounce. No, sorry. Actually, no, not that one. By applying the reverse distributive law for the OR form, we get with these two terms, we get not A and B or not B, or not A and C, which is the other term left over. And then by applying the inverse rule of the OR form, we know that this term is just 1. And 1 and anything else is just that anything else, which gives us not A or not A and C. And then we can apply the absorption law in the OR form, which just gives us not A. So this exact same circuit can be expressed simply by having A pass through a NOT gate to get Q. Oh, oh, I hope that was fun. Hope this helps, and let me know if you have any questions or concerns. I'll see you in the next video. Have a great day.